Okay, gentlemen, be prepared to be amazed because we're going to discuss trapezoids and kites. You know, go fly a kite sounds so much better than go fly a trapezoid. Okay, so a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called the bases. The non-parallel sides are called the legs. And the base angles are formed by the base and one of the legs. The trapezoid ABCD, angle A and angle B are one pair of base angles, and angle C and angle D are another pair. If the legs of a trapezoid are congruent, then it is an isosceles trapezoid. So if AD is congruent to BC in this picture, then we would say that trapezoid ABCD is an isosceles trapezoid. Okay, so if a trapezoid is isosceles, then each pair of base angles is congruent. All right, so in this case, if trapezoid FGHJ is isosceles, then angle G is congruent to angle H, and angle F is congruent to angle J. Okay, if a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. So if angle L is congruent to angle M, then the trapezoid is isosceles. We could say the same on the other side. If angle K was congruent to angle P, then the trapezoid is isosceles. So one of the rules of being an isosceles trapezoid is that the diagonals are congruent. So if triangle QRST is isosceles, then segment QS is congruent to segment RT. Likewise, if segment QS is congruent to segment RT, then trapezoid QRST is isosceles. Now, remember we talked about that if the diagonals are congruent, you could have a rectangle. Well, again, this only has one pair of sides, opposite sides parallel. So that's the difference. If it's got both pairs of opposite sides parallel, it's a parallelogram. If the diagonals are congruent, it's a rectangle. If that is not true, you only have one pair of opposite sides parallel. Now it's an isosceles trapezoid. All right, so we have an example here. The speaker shown is an isosceles trapezoid. So the measure of angle FGH, which would be this angle right here, FJH should say, is 85 degrees. And the measure of FK, which is this distance from here to here, is 8. And JG is, this whole length here, is 19. So the first question is, find the measure of angle FGH. Well, if this angle is 85, and we know that these two segments here and here are going to be parallel. So this angle here, let me get the highlighter going. So this angle and this angle are going to add up to 180 degrees. So we're going to say that 85x plus 85 equals 180. So x is equal to 95. Now, since this is an isosceles trapezoid, we know that this segment here is congruent to this segment here, but we also know this angle here is congruent to this angle up here. So angle JFG is congruent to angle FGH. So the measure of angle FGH is 95. We want to find the length of KH. Well, if this diagonal here, we're going to erase all this stuff up here. So we know that this diagonal is congruent to this diagonal. So if this part of this diagonal is 8 and this whole diagonal here is 19, well then 8 plus what is 19? Well, that would have to be that KH is equal to 11. So you're going to have to reason your way around it, just like that. Okay. So now we have quadrilateral ABCD as vertices at A at negative 3, 4, B at 2, 5, C at 3, 3, and D at negative 1, 0. Show ABCD as a trapezoid. Determine whether there's an isosceles trapezoid. So the first thing I'm going to do is I'm going to take a look at this by graphing it. So once you've graphed it, connected your dots, you've got something like this. Now, when I look at this figure, I'm going to pretty much decide that AD is parallel to BC. So those are the ones you'll now see in blue. So how do we show that those are parallel? Well, we find the slope. So the slope of AD is equal to y minus y, so 4 minus 0, over negative 3 minus, right, negative 3 minus negative 1, right? Making sure I've got the right thing here. So AD, all right, 4 minus 0, negative 3 minus negative 1. Yep, I'm okay. All right, so 4 over negative 3 minus negative 1 is negative 3 plus 1, negative 2. So the slope is negative 2. So now we're going to find the slope of BC. And they have to be equal. So this is, if they don't come out equal, then we do not have an isosceles, excuse me, we don't have a trapezoid. So we're going to subtract 5 minus 3 over 2 minus 3, and we end up with 2 over negative 1, which is also equal to negative 2. So the slopes are identical. So we can easily say then that segment AD is parallel to segment BC. Now the second part is to decide whether it is an isosceles trapezoid. And the way we have to do that is we have to figure out the length of AB and CD, and we use that doing the distance formula. So the distance of AB is equal to the square root of the x values minus the x values. So let's put AB here. So negative 3 minus 2. And we're going to square that. Plus 4 minus 5. And we're going to square that. So this is equal to the square root of negative 5 squared plus negative 1 squared, which is equal to 25 plus 1, which is equal to the square root of 26. And we don't have to do anything further. We can leave it in radical form, because all we're doing is see if they're going to come out equal. So next we're going to subtract, or excuse me, we're going to find the distance of CD. So the distance of CD equal square root of the x values subtracted plus, and then squared, y values subtracted and then squared. It doesn't matter which one you do first, x or y. We've done this before. We know that basically this is a it's irrelevant. Basically, we can do y's together, x, and then square that x's because we're adding. So we're going to say 3 minus negative 1 plus 3 minus 0. Well, 3 minus negative 1 is 4. We're going to square that. Plus 3 minus 0 is 3. We're going to square that. And we're going to end up with 16 plus 9, which is the square root of 25, which is equal to 5. So ABCD is not isosceles, but it is a trapezoid. Okay, so next we want to talk about the midsegment of a trapezoid. Midsegment of a trapezoid is a segment that connects the midpoints of the legs of the trapezoid. So you're looking for that and that. Those are midpoints, right? That's going to be a midpoint right there because those two segments here are congruent. This is going to be a midpoint here because this segment and this segment are congruent. So those are our clues. I should have erased those before all that. Okay, so the trapezoid mid-segment theorem is this. The mid-segment of a trapezoid is parallel to each of its bases and measure is 1/2 the sum of the lengths of the bases. In other words, it's going to be the average between these two. So you're going to average, if this is AF, add it to CD divided by 2, or multiplied by 1/2. And BE is going to be parallel. So all right, so here we have this figure. So segment LH is the mid segment. They're telling us this, and they want to know what's the value of x. So we have to keep in mind that no matter what, the value of LH is going to equal 1/2 of FG plus KJ. So now you just plug in. So 15 equals, I'm going to do this. When I multiply by 1/2, I can put this over the fraction bar, the whole thing. So FG is x, and KJ is 18.2. Oops. So first thing I want to do is I want to get rid of the fraction bar. So I'm going to multiply each side by 2, and I've got 30 is equal to x plus 18.2. So now we're just going to subtract 18.2 from each side. And so x is going to be equal to 11.8. Okay. So the value of x is 11.8. Okay, kites, properties of. Kites is a quadrilateral with exactly two pairs of consecutive congruent sides. So in this case, we would see that segment SP is congruent to segment SR, but they're not congruent to segment PQ, which is congruent to segment QR. All right, so unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. Okay, so kites have some very specific characteristics. Number one, the diagonals are perpendicular. So if quadrilateral ABCD is a kite, then segment AC is perpendicular to segment BD in this picture. Okay, so if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So in this picture, we can see that it's going to be the pair of angles between the two non-congruent sides. So they are always going to be found, you'll see here, these two sides are not congruent. So the angle in between, again, is going to be the same way, right? And we can prove that very simply by, we drew a line here. Oops. We draw a line right here. Those two triangles are congruent by side, side, side. Therefore, those opposite angles would now be congruent by CPCTC. Okay. So, if FGHJ is a kite, find the measure of angle GFJ. So, basically, because this is a kite, we know that these two angles here are congruent. So, since they're congruent, I'm just going to put x's in for both. And then I can take and add up all of those angles and make them equal to 360, because the sum of the measures of any quadrilateral is always 360. So I'd end up with 2x plus 200 equals 360. Subtract 200 from each side, 2x equals 160. So x is equal to 80. Okay, so another way we can do this is we can take this idea where if I draw on a diagonal from G to J, I know that those two triangles are congruent. So I know these angles are going to be cut in half. So half of 128 is 64, half of 72 is 36. Those add up to 100, so this one has to be 80. The third method is a little more complex than that, and that is where we would take and draw our diagonal this way. So if this angle is 128, these angles here would have to be, let's say those are x, well, they have to add up to 180, right? So that would be 52, and half of 52 is 26, so this would be 26. Same rule here, 72 degrees, that would be 108, that would be 54. If you add 54 and 26, you end up with 80. So there's a couple different ways of doing this. None of them are wrong, but it depends on what information is given to you and what method you want to use to solve. Alright, so if WXYZ is a kite, find ZY. Well, ZY is this segment right here. And what we have here is a right triangle. So we can say that WP, or ZP, excuse me, which is 8 squared plus 24 squared would equal ZY squared. So 8 squared is 64. And 24 squared is 576. And that's going to be equal to ZY squared. So this comes out to 640 is equal to ZY squared. So we would take the square root of each side, and we would come out with ZY is equal to square root of 640. And we would leave it like that at this time. We don't need to do anything. Some people would want to hit the square root sign on their calculator and find out this is approximately 25. Let's say they said to solve it to the nearest tenth, so 25.3. We wanted to do radical simplification. This would be the square root of 64 times the square root of 10. We know the square root of 64 is 8, so that would be 8 square root of 10. So it's our final problem of the day. Stay healthy and do your homework.
That's all, folks.